Dear students, in our previous class, we have discussed regarding traversing a linked list and then memory representation of a linked list. But in our today's class, we are going to discuss about inserting a node into the linked list and also deleting a node from the linked list. First, we shall see inserting a node into the linked list. Into the linked list. The students, in our previous class, I have explained you under memory representation of linked list. That is, if a node is deleted from the memory, that is shifted to avail list or the avail memory, and when needed again, we can restore the node. The same process is here. Sometimes we want to insert a node into the linked list. At the time, if a node is present under the avail list, only at that time we can insert a node from avail to the linked list. If there is no node under avail list, then it is not possible to insert a node into the linked list. Hope you have understood. If a node is present in avail list, then only we can insert a node into the linked list. If there is no node under avail list, then we cannot able to insert a node into the linked list. So here, inserting a node into the linked list includes three steps, three types of insertion. The first one is inserting a node, inserting a node at the beginning of linked list. At the beginning of linked list. At the beginning of linked list. The next one is inserting a node at the end of linked list. Inserting a node, we shall take the second one as at given position. At given position. Then finally, the third one is inserting a node, inserting a node at the end of linked list. At the end of linked list. Okay, inserting a node at the beginning of linked list, inserting a node at given position, and also inserting a node at the end of linked list. Now we have to discuss one by one. First, we shall discuss inserting a node at the beginning of linked list. How can we insert a node at the beginning of linked list? It has some rule. Everywhere in every linked list, a star pointer is there. If you want to insert a node or if you want to create a linked list, the first node has to be connected to the start pointer, which can also be called as a head pointer. Okay, then only we can able to connect the number of nodes to that start pointer, then it will become a linked list. So here also the start pointer plays a vital role in inserting a linked list. Come, we shall see how can we insert. Start is a pointer that contains the memory address of that contains the memory address of the first node, the memory address of the first node. Okay, start is a pointer that contains the memory address of first node. I will show you afterwards, then you will come to understand. Then, to insert an item into the linked list or to insert a node into the linked list, we need to follow these steps. To insert an item, we can be called as a node. Okay, into the linked list, into the linked list. The following procedure is used. The following procedure is used. Okay, what is that procedure? To insert an item, that is a node, into the linked list, the following procedure is used. First one, create a new node. Create a new node. Okay, first we have to create a new node. Then later, okay, think that we have created a new node here. We have created a new node. Okay, next come second point. What the second point states? Fill the data. Fill the data into the data field of the new node. Okay, first what we did, create a new node. We have created a new node here. Then we have created a new node. Then fill the data into the data field of the new node. Every node is having two fields. One is the data field, the other one is the link field. Okay, this is data field. Okay, the next one is the link field. So this, according to second step, okay, fill the data into the data field of the new node. We will fill some amount of data in the data field of the new node. Then after that, third point, mark the next pointer field. Mark the next pointer field. Next pointer field. Next pointer field as null. Okay, this pointer field. Okay, here there is no space that side, so I will take below here. Okay, so this can be marked as null. Okay, look, here space is not there, so for that reason I am taking down. Okay, mark the created a node. Okay, then fill the data field of the new node field. Then mark the next pointer as null field. Okay, third step. Next pointer is marked as null field. Attach the newly created node. Attach the newly created node. Attach the newly created node to the start pointer, or we can write as to start. Okay, attach the newly created node to start. So this can be connected to start. Take this pointer as start. Okay, This newly created node is going to be attached to the start. Okay. Then finally, make a new node as the make a new node as the starting node. Okay. Make a new node as the starting node. This means, okay, new node itself has created. By following all the four steps, make this node as the new node. Like this, we can insert a node at the beginning of the linked list. First, we have to create a new node, then fill the data field of the node with data. Next, mark its link field to null, then attach or connect that node to the start pointer. And finally, the last point is by following all these steps, this new node has become the starting node. So like this, we can insert a node at the beginning of the linked list. Now we shall see the second point. Insert a node at given position. Inserting a node at given position. And okay, inserting a node at given position. In the middle of the linked list, how can we able to insert a node here? Okay, we can insert a node at the given position by following certain steps. Okay, that is here the following procedure inserts the following procedure inserts a node at the given position. At the given position. Okay. According to your syllabus, what I will going to explain you under this. Okay. Inserting a node at given position, you need to remember those things, and you have to write those things. Okay. If we have created a linked list, okay, this is start pointer. Okay, and we are going to create a linked list here by creating two or three nodes. Okay, take this as node 1. Okay, then node 2. Okay, then node 3 and node 4. Okay, just we'll create a linked list for 3 nodes. Okay, this is a linked list. It contains some data. Okay, 10, 20, 30, whatever it may be, then this is pointed to null always because it is a singly linked list. Now, Inserting a node at given position means now I want to insert a node in middle of these two things. Take this as node 1, okay, and this as node 2, and this as node 3. Okay, what we have to do? We want to insert a new node in between these two nodes here. At the time, first we have to mark this null pointer as this link field as null pointer. Okay, if we mark this link field as null pointer, then what will happen? Then this node will get separated. Okay, node 3 will be shifted here. Okay, 30, and this is pointed to null. Okay, null. Now we can take one more thing I will show you this. Okay, 30, and this will be marked as null. Okay, if we mark this pointer to null, then at that time what will happen? The link between these two will be breaked. Okay, then we have to create a new node by following the first procedure. Okay, we have to create a new node. Take this as 25. Okay, if we make this pointer null, then the node which is connected to this pointer will be broke out. Then after that, create a new node. Then to this link field, give the address of the new node. To this link field, give the address of the new node. Okay, then for this link field, for the new link field of the new node, give the address of this node. Then at the time, a node can be inserted. Okay, we can take this as new node. This is node 3. Okay, look here. First, in a linked list, okay, mark the node in the place where we want to insert the new node. Mark that node field, okay, that node link field as null pointer. Then the remaining nodes will come out of the linked list. Then create a new node. Okay, then mark the null pointer of a previous node. Okay, give the null pointer of a previous node, give the address of a new node to the null pointer of previous node, and then for the break or the broken node, okay, give for the new node, give the address of the broken node. Then at the time, a new node can be inserted in between the nodes, or a new node can be inserted at given position. Inserting a node at a given position. Once again, I will explain you. Maybe you have not understood. If you want to insert a node at the given position, okay, the place where you want to insert a node, okay, give the link field of the previous node as null. Then what will happen? Then the remaining nodes will come out of that linked list. Create a new node and give the address of the new node to the previous node null field. Okay, then give the address of the broken node, okay, to the new node. Then the new node will going to be inserted at a given position of the linked list. If we do like this, then a node can be inserted in between the linked list or at the given position of linked list. Then finally, the third one, inserting a node at the end of linked list. inserting a node at, sorry, this one is third, inserting a node at the end of linked list. At the end of linked list. Okay, how can we insert a node at the end of linked list? We can insert a new node. We can insert a new node at the end of linked list. At the end of linked list. At the end of linked list. Okay. To insert at the end. To insert at the end, we have to traverse a linked list. What is meant by traversing? Traversing means accessing each node exactly once to perform some operation. It's called traversing. We have to traverse. To insert an end, okay, we have to traverse the linked list. Traverse the linked list to know the address of last node. To know the address of last node. To know the address of last node. Okay, we will create a linked list here. Start. Okay, then 1, 2, and 3. Okay, we are having 3 nodes in a linked list. We want to insert an item or node at the end of the linked list. Then what we have to do? We have to insert at the end. We have to traverse the linked list. Traverse means we have to access each, because to get the address of the last node here, null is there. Last node contains only the null pointer to know the address of the last node. If you find the address of the last node, at that time create a new node. Okay, create a new node and you link the address of the new node to the link field of the last node. Okay, connect the address of new node to the link field of the last node. Then finally the link field of the new node will be marked as null. If we do like this, we can insert a node at the end of the linked list. Hope you have understood this thing. Okay, inserting a node at the beginning of linked list, and inserting a node at the given position of linked list, and inserting a node at the end of linked list. After this, we shall going to discuss the deletion of a node from the linked list. And deletion also includes 3 types: deleting a node at the beginning of linked list, deleting a node from the given position, and deleting a node at the end of linked list. Before going to that, we shall going to discuss two important things. Among that, first is the garbage collection. We shall see what actually the garbage collection means. Okay, garbage collection. First, I will write the explanation. Then I will explain you. After that, you will come to know exactly what the garbage collection means. If a node is deleted, if a node is deleted from the linked list, if a node is deleted from the linked list, or the linked list is deleted, or if a linked list is deleted, if a linked list is deleted, we require the space to be available for future use, okay. If a node is deleted or a linked list is deleted, okay, the place or the memory space from where the node or linked list is deleted, and that space, okay, will be available for future use. And then of this, the memory space of the deleted node or deleted linked list, deleted nodes is immediately inserted into the free storage, the operating system of the computer periodically collects all the deleted space, into the free storage. Space into the free storage list. This technique of collecting deleted space into free storage is called garbage collection. Here, dear students, okay, if a node is deleted from linked list, we have a linked list. From that linked list, if we delete a node, or from computer memory if we delete a linked list. Then that node or that space from where the node or the linked list is deleted, that space will be available for future use. After that, what will happen? The memory space, okay, from where the nodes are deleted, that space will be moved to the free storage. Okay, the place or the memory space from where the nodes are deleted. Okay, think this is a memory space, it is having a node. Okay, it is having a node. Now the node is deleted from the memory space, then this space is available for future use and this space will be moved to the free storage. The memory space will be moved to the free storage. It means whatever we want, we can store there. It will be moved to the free storage. And what the operating system will do? The computer operating system often and often, whenever the nodes are deleted from memory, it will collect that memory space to its free storage. And this process of collecting the deleted space to the into the free storage is called as a garbage collection. Okay, just like I will give you an example of garbage collection. You have a cover, or you have, yes, you have a cover, or you think that you are having a geometry box. Okay, in that you kept your instruments just like pens, pencils, rubbers, and so on. You are making that geometry box, your toolbox, your geometry box empty. Then think that geometry box as free space which is available. Again, we can put your tools in that geometry box. Okay, at the time when your pens or your tools are removed from your geometry box, then your geometry box will become empty. That means the node or the linked list is deleted. Okay, then that space will be available for future use. Then that geometry box have become free. It is having space. You can use that geometry box in future for keeping some more things. Okay, then at that time what will happen? Then your geometry box will be moved inside your bag. That geometry box will be moved inside your bag. Geometry box is a available space. Okay, your bag is like a free storage. Your geometry box is moved to your bag. What the computer will do, like this, the available space which is your geometry box, like this type of space, this type of storage will be often and often collected by the computer memory. Okay, the deleted space will be moved to the free storage, just like you are emptying your geometry box and moving that empty box into your bag. When needed, then that memory is again taken and again inserted tools. So this process of collecting the deleted space, okay, collecting like your empty geometry boxes, that is called as garbage collection. Okay, you have understood this. Next come one more thing, that is underflow. One more thing, that is underflow. What is meant by underflow? You know the two things. One is overflow, another one is underflow. For deleting a node, you need to understand regarding underflow. Underflow means, what is underflow? If we try, if we try to delete a node, from where we will delete? From linked list. From linked list. If we try to delete a node from the linked list which is empty, which is empty. Okay, this condition is called, this condition is called, is called underflow. Okay. I will give you an example. Think we are having a linked list. It contains some nodes. Okay, one, two, three. These things as nodes. Okay. If we want to delete an item from this linked list, then items are there. We can easily delete the item number 2. Okay. I think we are having a linked list which is empty, which does not contain any nodes. If you try to delete a node from this linked list, which is empty, okay, then the process of trying to delete a node from the empty linked list is called as underflow, because there are no items, there are no nodes. Even though we are trying to delete item from the empty linked list, that is called as underflow. Come now we shall discuss deleting a node from the linked list. Deleting a node from the linked list. From the linked list. It contains three things, same as deleting a node at the beginning or from the beginning. We can make simple as deletion of the first node. Deletion of the first node. Okay, that means deleting a node from the beginning of the linked list. Come, we shall see how can we delete a first node. We can easily delete we can easily delete the first node from the linked list we can easily delete the first node of the linked list by changing the start by changing the you can write this as start by changing the start to point to the second node to point to the second node of the linked list of the linked list if there is only one node in the linked list if there is only one node in the linked list, the start can be the start can be stored with null. The start can be stored with null. Okay, listen here. We can easily delete the first node of the linked list by just changing the start, okay, to point to the second node of the linked list. Okay, think we are having a linked list start, okay, which is having two nodes, okay, which is having two nodes, that is 10, 20. How can we easily delete a first node? The condition here is by changing the start, okay, to point to the second node of the linked list. Okay, what we will do, we will change this pointer from here. Okay, we will change this pointer from here and we will make it to connect to the second node. Just changing the pointer from first node to the second node. At the time, what will happen? The first node of the linked list is going to be deleted by changing the start point to the second node. Okay, by changing the start point to the second node. If and what if there is only one node in the linked list? Think that we are having just only one node in the linked list. At that time, what will happen? Okay, the linked list, the start can be stored with null. Then what will happen? If we store or we connect this pointer to the null, then the existing node will going to be deleted from the linked list. Like this, we can delete the first node of the linked list. Come, we shall see the next thing. Deleting a node at the end. Deleting a node at the end. Or, okay, deleting a node at the end. Okay, we want to delete a node at the end of linked list. Then what we have to do? We have to do this. To delete the last node, what we have to do? We should find the location of the second last node. The second last node. Okay, remember this thing, second last node. Okay, by assigning null to the by assigning null to the link field of the second last node. Okay. By assigning null to the link field of the second last node. Last node of the linked list last node of the linked list can be deleted. Okay, by two nodes. Just we'll take two nodes, or we can take three nodes. So, okay. 10, 20, 30. What we have to do to delete the last node? Okay, we should find the location of the second last node. Second last node means this is last node, and the node which is next to the last node is called as second last node. Okay, second last node means this is last node, and the node which is next to or before last node, or the node which is preceding the last node, that is called as second last node. So we need to find the location of the second last node. Then by assigning the link field of the second last node to null, by assigning the link field of the second last node to null, then by assigning the link field of the second last node to null, we will assign this link field as null. Then at that time what will happen, this last node will be deleted. Okay, if we assign null here, then this will be, the null pointer will going to change. The null pointer, this null pointer will come here. Okay, first of all this node is connected to the last node, then we have assigned this link node, this the link field of this node to null, then this node will be deleted, and the link field of this node also become null. Like this we can delete a last node of the linked list. Now we shall see the last thing, that is deleting a node at given position or at the middle. Deletion of node at given position. At the given position, we need to follow some steps here to delete a node at the given position. The first step is to delete the node at given position, the following procedure is used. The following procedure is used. First point, what we have to do to delete a node from the given position. First we have to do is find the location of the node, to be deleted. Okay, first we have to find the location of the node which is need to be deleted, and the previous node, Okay, think we are having a linked list. This is start. Okay, then 1, 2, then 3. Now I want to delete this node. Okay, I want to delete this node. So we have to find the location of the node, location of this node to be deleted, and the previous node and the location of this node. Okay, then what we have to do? We have to do is delete the node, delete the node to be deleted. Okay, delete the node which is to be deleted. How can we delete? By changing the location of the previous node, by changing the location of the previous node of the node to be deleted, of the node to be deleted. Okay. What we have to do is find the location of the node, location, and the location of the previous node. Then delete the node by changing the location of the previous node. By changing the location of the previous node, just change the location of the previous node. Okay. At that time, what will happen? Okay, the node which is in the given position will be deleted. The node in the given position will be deleted. We have to do is, okay, delete the node, okay, by changing the location of previous node. Okay, just changing the location of previous node. Okay, then this node will going to be deleted. The node which we want to delete, we have to find the location of that node, and first we have to remove the location of this node. Then we need to remove the location from here. Then we have to give the location to the next node from previous node. At that time, the node will be deleted from the position. Like this, we can delete a node from the given position. So today we have discussed inserting a node at the beginning and at given position and at end, and also garbage, then underflow. Then after that, deleting a node from the, or deleting the first node, deleting the last node, and deleting the node at the given position of the linked list. Hope you have understood today's class. In our next class, we are going to discuss the last classification of linked list, that is trees and graphs. If you have any doubts regarding today's class, you can ask me personally. Thank you.